1.4, complex number preparation, continued. Adding polynomials. To add two polynomials, combine, add like terms. Find each sum horizontally. Okay, horizontally is basically what it says. The horizon goes left to right like this, so, you know, sunlight. Okay, so horizon is this thing right there. Vertically would be like this. It'd be like columns, right? Go up and down. Okay, so finding the sum horizontally. Basically what you do is you would combine like terms. Usually you want to start with the highest term degree that you see. I see a third degree there, but I also see a third degree term there, and that's the highest term that I see. So I'm going to deal with that first, right? So we're going to say 6x cubed minus 2x cubed, and that should give us a 4x cubed. Now when you're adding and subtracting polynomials, only the coefficients are added or subtracted together. The exponents do not change. That's important. Okay, so now let's move on to the next one. We see a second degree term right here, and we also see a second degree term over here. Okay, so now we're going to say negative 4x squared plus 7x squared. Negative 4 plus 7 is 3, and now we have x squared. Again, the degree did not change when we add and subtract. Next, we see a positive 3 and a negative 5. So positive 3 minus 5 is negative 2, and we are done. Now let's try the next one. Again, we're going to add these horizontally. So we want to start with the highest degree. Now in this case, you see a 2x squared, so this degree here is 2. But over here on the second one, we actually have a third degree, right? So we're going to use the third degree term first. Okay, we want to put it in descending order. So this is the first one we deal with. Then we're going to skip over here, right? So we had third degree first. Now we have the second degree, so plus 2x squared. Okay, then we see a first degree, right? So we say minus 4x. Then we deal with the constant. We have a 3 plus 5, which gives us an 8. Okay, now we want to add them vertically. Now adding them vertically is going to be a little bit extra work, but sometimes it's worth it, especially if you're adding together very long polynomials. I mean, depending on how far you go in math, you might have 10 plus terms, in which case adding them vertically actually might be easier. But for the short ones, generally speaking, the rule of thumb would be if they're short, probably want to add them horizontally. If they're long, might want to switch over to vertically. But some people do everything vertically because they just find it easier. Okay, now if you are going to do that, make sure that you line up like terms. So for instance, right here I have 6x cubed. Over here I have negative 2x cubed. So I put the negative 2x cubed right there. Okay, and now we have some squares right here. We also have some squares over here. So we are going to say minus 4x squared plus 7x squared. And then we have some constants. So we have a positive 3 and a negative 5 here. Positive 3, negative 5. Now, that might have seemed like a lot of work, the fact that I was keeping track of the degrees. Excuse me. The degrees. But you have to make sure that all like terms add up. So if I'm missing a term, a degree term, within the first or second one, I still need to leave an empty space there. I may put a 0 as a placeholder. And I'll illustrate that on the next one. This is a little easier than the first one. Okay, so now we add like terms, right? So we say 6x cubed plus negative 2x cubed gives me 4x cubed. Again, when you add and subtract polynomials, the exponents do not change. Then we say negative 4x squared plus 7x squared, so that gives me plus 3x squared. Then we say positive 3 plus negative 5 gives me a negative 2. Okay, now let's move on to the next one. The highest degree that we see here is the x cubed, right? And the next one that we see in descending order is a 2x squared. And then over here, now you can put a 0x squared here, and that's pretty formal way of doing it, or you could just leave it blank. Either way is fine. But you do need something there, usually a placeholder. Next, we're going to go to first degree right there. So now we're moving on to, that is a negative, not a positive. That is a negative 4x, right? So third degree, second degree, first degree, right? So, and then we're even going to put the plus 3. Okay, now on the other one, we say plus 5x, okay, and then you can put a 0 here, or you can just leave it blank. Either way is fine. Now you're going to add these together. Now if you don't see anything, you're just going to drop it down, right? So your first thing here is you're going to drop down the x cubed. Then we say 0x squared plus 2x squared. Obviously, you can just drop down the 2x squared because you're not really adding it to anything. Then you say negative 4x plus 5x. Negative 4 plus 5 is a 1x, or just an x. You don't actually have to put a 1 there. And then 3 plus 0, or of course, is just 3. So you can put 0 there as a placeholder, or you can just leave it blank. That's fine too. But just again, you need to have the like terms lined up. So the degree should match whether you actually see the degree, it's understood to be 1, or it's a constant, and the degree is understood to be 0. You just need to line them up. Okay, so now subtracting polynomials. Same kind of thing. Make sure they're like terms, then add or subtract their coefficients. So find each difference. Now, there's something a little bit different in here in that there's two ways of looking at this. One is you can think of the negative 1 as being distributed within there, in which case you are going to say negative 1 times positive 3x gives me, a negative 3x. And you would say negative 3x, and then negative 1 times negative 8 gives you a positive 8. Then you would combine like terms. 5x minus 3x is 2x, and negative 2 plus 8 gives me a positive 6. And that's it, you're done. Another way of looking at it is just flip all the signs inside, right? Positive 3x turned into negative 3x, negative 8 turned into positive 8, right? So either think of it as distributing a negative 1 or just flipping all the signs. You get the same result either way, whichever makes more sense to you. Now, be careful because order matters in subtraction, right? So the commutative property of addition would be something like, 2 plus 3 plus 5, 3 plus 2 equals 5. Okay, a commutative property also applies to multiplication. 2 times 3 is 6, 3 times 2 is 6. But it does not apply to subtraction. 2 minus 3 is negative 1. 3 minus 2 is positive 1. All that really means is order matters for subtraction. So whenever you're doing subtraction, almost half the time, it's not going to be the order in which it is written. And you just need to either memorize the terminology or the pattern, or you can do a little bit of experimentation and figure it out, right? Okay, so we're saying we're going to subtract this from this. Now, when they say from, you're actually going to have to flip the order. And what that means is really you're taking 11x cubed plus 2x squared minus 8, right? And you are going to be subtracting 6x cubed minus 4x cubed plus 2. Okay, so I'm going to distribute the little negative. So 11x cubed plus 2x minus 8, and that is, of course, x squared. And then we're going to flip all the signs. So positive 6x cubed turns into negative 6x cubed. Negative 4x turns into positive 4x cubed. Sorry, squared. Squared. And then finally, positive 2 or plus 2 turns into minus 2. Okay, now we combine like terms. 11x minus 6x cubed would give us a 5x cubed. Again, you add and subtract, the exponent does not change. Next, we would say there's a 2x squared plus a 4x squared. 2 plus 4 is 6x squared. Then you say negative 8 minus 2 gives me negative 10. Now we can each find each difference vertically. Same kind of thing. These are a little bit longer, so this more justifies doing it the vertical way. Again, the short ones, it's just easier usually to find the like terms and add horizontally. But as they get longer, it makes more and more sense to do this vertically. I'm going to be lazy and not even rewrite the first one, so I'm just going to rewrite the second one underneath. So 2x cubed minus 7y squared minus 4y plus 6. Now I do have to point out, since I'm subtracting, right, I can either distribute the negative to all of these and flip all the signs here and then write it vertically, or I can, and this one's a little more confusing, is to write it this way and then subtract vertically like this. So, it'd be a 14y cubed minus positive 2y, so 14 minus 2 is 12. I'll finish doing it this way, but I want to point out, if you're not very good with signs, this is not probably the optimal way of doing it. I'll show you another way. Okay, so then we have negative 6y squared minus negative 7y. 6 minus a negative 7 is the same as negative 6 plus a 7, which gives me a positive 1y squared. And that's where dealing with the signs gets a little more difficult. You say 2 minus negative 4. That's the same as 2 plus 4, which would give me a 6y. And then finally, you say negative 5 minus 6, which would give you negative 11. Now, if you find that confusing, and I would understand, what you would do is you would distribute the negative, right? So you distribute the negative, so that would turn into negative 2y cubed, positive or plus 7y squared plus 4y, and then minus 6. And then what you would do is you would just rewrite it after distributing the negative. So you don't have to distribute the negative. If you're pretty good with your signs, you can just subtract dealing with the negative. But if you're making sign errors, I would recommend you rewrite the whole thing after distributing the negative, so it gives you one less sign to have to deal with. And now you would just add everything, right? Because this can get a little confusing. You have to deal with some double negatives. Make sure you put a 2 right here. There we go. All right, so we say 14y cubed plus negative 2y gives me a 12y cubed. We say negative 6y squared plus 7y squared, which gives me a y squared. We say positive 2y plus 4y gives me a plus 6y. We say negative 5 plus negative 6, which gives me a negative 11. Okay, so let's try to add the last one vertically. So right here we are going to rewrite everything. So we could rewrite the first one. Let's see, the highest order, or the highest degree of all these is squared. So we're going to say 3x squared minus x plus 4. Now the degree is always in front, so this is actually a positive 4, so I put a plus in front of it. I put the negative in front of that x, so we always put the sign in front, right? Now the first one is just implied or understood to be positive, so you don't actually have to put it there, right? It's just understood or implied to be positive. Okay, so we do the next one. I'm going to distribute the negative and flip all the signs. So here we go. Negative 1 times 2 is negative 2. Negative 3 times negative 1 is a positive 3x. Negative 1 times a positive 5x is a negative 5x squared. We can distribute that if we want to, but there's really nothing to distribute, right? Okay. Now at this point, we should be ready for rewriting everything. Okay, so the first one's going to be 3x squared minus x plus 4. Next one is going to be, see right here we have a 5x squared, right? So we're going to say negative 5x squared. Then we say plus 3x. And then we say minus 2. And then we have a negative 4x squared. And then we have a plus 2x. And then we have a plus 8. And we just add everything together. 4 minus 2 is 2. 2 plus 8 is 10. Negative 1 plus 3 is 2. 2 plus 2 is 4. And then we say 3x squared minus 5 is negative 2. Negative 2 minus 4 is negative 6. X squared. And there we have it.